Okay, so we are continuing to look at elastic, one-dimensional elastic collisions. So one-dimensional elastic collisions, and that's going to mean two very important things. Momentum before equals momentum after, and that is conservation of momentum. And then we're also going to have and that kinetic energy before equals kinetic energy after. That is going to be okay. And as long as I'm just sort of writing this, I want to say that I want to throw this in here. Okay, no collision is perfectly elastic, which means that you never have total perfect conservation of kinetic energy. You're always going to lose some to deformation of the object, and some of it's going to be converted into heat. And then no collision is perfectly inelastic, although you can get very, very, very close to a perfectly inelastic collision if you have sort of a bullet going into a block of wood, or if you have a piece of damp clay landing on a surface. Those are pretty much inelastic collisions. Okay, so let's set up what we're going to do over the next 2 or 3 videos. We're going to come up with just an arbitrary mass. And we're going to just make this as difficult as it can possibly be. Well, we could probably make it in one dimension. Okay, so let's make that 1.38 kilograms. Let's make this 2.57 kilograms. Let's make this heading this way at 1.29 meters per second. And let's have that heading that way at 3.02 meters per second. Just making up numbers off the top of my head. Okay, so it's going to take us a while to do this, but we'll get it all set up. Okay, so what we're going to do is we're going to have M1, V1I, V1F, M2, V2I, V2F, and we're going to have M1 is 1.38 kilograms, V1I is 1.29 meters per second, V1F is going to be like the last thing we find. M2 is going to be 3.02. I'm sorry. Lots of numbers running around. 2.57 kilograms. V2I is going to be 3.02 meters per second, and then this is going to be the first velocity that we find when we get done with things. Okay, so let's just start off. We have M1 V1I plus M2 V2I equals M1 V1F plus M2 V2F. And so we plug in there 1.38 kilograms. V1I is 1.29 meters per second. And then M2 is going to be 2.57 kilograms. V2, oops, I knew I was going to forget. It's pointing that way. So we have to make this negative. That's positive, that's negative. So we have to make that a negative. Got to remember those directions. Okay, equals 1.38 kilograms V2F, V1F, plus 2.57 kilograms V2F. Okay, so we can do this whole side of it just on the calculator. 1.38 times 1.29 minus 2.57 times 3.02, because I just remembered to bring the minus out front, and I get negative 5.98 kilogram meters per second equals 1.38 V1F plus 2.57 kilograms V2F. And now I'm going to divide the entire thing by 1.38. So I'm going to get divided by 1.38. I'm going to get negative 4.33 meters per second. Oh, that's got units of kilograms. Equals V1F plus 2.57 divided by 1.38, 1.86 V2F. Okay, so finally I'm going to end up with V1F is equal to negative 1.86 V2F minus 4.33 meters per second. Okay, and so that's where we're going to end this video, and then we're going to start off in the next video. We're going to plug this into the start plugging this into the conservation of kinetic energy equation.